so moving on to the second lesson, or the third lesson, technically. So what we are looking at is we're going to compare graphical models. Okay, so we're going to look at equations, two different equations. We're going to graph them. We're going to see how do they compare, which one is better, and which one should we choose if we are going to choose. So what we have here, we have two different deliveries or shipping companies, and then we have the equation of these two different companies. And then what we have here, we have Donnie's deliveries, which is C equals 3.5 plus 4.75 M, and Susan's shipping is C equals 5 plus 4 M. Now, when I'm looking at these two equations, I need to first analyze what these equations mean, right? So C means the cost, and M probably means, I need to go to the previous page, 1 second. It's too far. Okay, what does it say here? And M represents the mass of the package in kilograms. So C represents the shipping cost in dollars, and M represents the mass of a package in kilograms. Okay, so suppose you need to ship a package and you are trying to decide between two different delivery companies, and you know there are shipping charges. Which one would you pick? So if I'm looking at this, the first thing to analyze this, what I have here is I have C equals, I'm going to rewrite this a little bit, and then I'm going to write it as 4.75 M plus 3.5. And then for the second one, C equals 4 M plus 5. So if you recall, this is a linear function. And if you recall with linear functions, we have y equals mx plus b, where m is the slope of the line and b is the y-intercept. Okay, so m, slope means rate of change. So what we've done in the previous lesson. And the y-intercept is basically your initial cost. So without, if it doesn't matter what your mass is, right? You're gonna start paying this much, all right, before we even weigh that package. Okay, so that's even if your package is 0 kilograms. Okay, so if I'm looking at this equation here, it looks like 4.75 M, right? So 4.75 is the slope, and M is the mass. So M in this case is replacing the X, okay? And then this is going to be the y-intercept, so 3.5, okay? So I'm gonna pay $3.50 no matter what, plus the 4.75 per kilogram. For the second equation, my y-intercept is 5. So I'm gonna start paying $5 to start with, plus the $4 per kilogram. Okay, so what we're gonna do, we're gonna use decimals to graph these two equations and to compare the graphs. Okay, so let me go back here and let's see what we have. All right, so what is the starting price for each delivery company? So we already discussed that, and we said the starting price is $3.50 for the first one and $5 for the second one. How are these initial conditions represented on the graph? So if I'm going to graph this, so this is decimal, C equals 4.75 M plus 3. What was the equation? Oops, wrong one. 3.5. And for the second one, C equals 5, I think it was 4M plus 5. Let's just double check. So 4M plus 5, and then 4.75 M plus 3.5. All right, so I'm looking at these equations. The red one is the first equation, the blue one is the second equation. So for the red one, it's starting at 3.5. okay? So my starting price is 3.5, and as it increases, now I don't really care about the negative part because I'm not gonna have negative kilograms. So basically I'm comparing this, right? And I'm starting at 3.5, it's going up. For the second one, it's starting at 5 and it's going up. All right, now, so if I'm going back here, the second question is asking me what are or how are these initial conditions represented in the graph? It's the y-intercept, right? So that 3.5 and that 5, they are my y-intercept. So 0.3 and 3.5 and 0 and 5. The lines representing the delivery costs for each company have different slopes. Explain the significance of this context in the context of the problem. So remember that the slopes mean the rate of change, right? And the slope in this case, for the first one, it was 4.75 n, right? So that means for each kilogram, because m represents the mass in kilogram, right? So for each kilogram, you will be paying $4.75. In the second equation, it's 4n. So that means that for each kilogram, you will pay $4. Okay, so that's $4 per kilogram for the second equation, $4.7 per kilogram for the second equation. All right, so remember that it depends on the mass. All right, here's another example. So 2 large containers are filled with water. A hole is punched in the bottom of each container, and the water drains out. The relationship between time and volume of water in each container is shown by the following equation. So I have the 2 equations. Use technology to graph both equations on the same axis. Adjust the window setting to accommodate time values between 0 and 8 minutes and volumes from 0 to 700. Okay, so let's do that together. So I have the equation, V equals 24t squared minus 240t plus 600. So V equals, I forgot what it was, 24t squared minus 240. So to do the square, you have 2 options. You can use this here to put the square. Okay, so 24t squared minus 240t and plus 600. And the second equation was 10t squared minus 140t plus 490. Or you can do shift and the hat, and then that will give you the square. So 10t squared minus 140t, I think plus 490, but we'll check that. Yeah. All right, so it says set your window to accommodate time value between 0 and 8 and the volume between 0 and 7. So time is t, and which is on the x-axis, and the v is the volume, which is on the y-axis. So I'm gonna go back here, and then how do we do that? So we do that by clicking that branch, and then for the x values, we're gonna pick 0 to 8. And then for the y values, we're gonna pick 0, I think it says 0 to 700. All right, and that would be my graph. You can pull it up a little bit just so you can see. All right. You can always move your graph left, right, whatever. Here are the good graphs. Now, if you're working on this and you wanna copy the graph, so if you're using a MacBook, you can do Command-Shift-4, and then you can snip it, All right, and then you can, now you're snipping your pictures on your desktop, then you can copy that desktop into your Word document. If you are using any other kind of computers, you should look for the snipping tool, and the snipping tool will be able to do the same thing, okay? Now let's go back here. So now we have the graphs. What type of functions is represented by each equation? So if you're looking at the equation, it's not linear, it's not a line, it's a quadratic, okay? It's a parabola, so it's a quadratic function. We know it's quadratic because it's also degree 2. Explain why the domain of each function must be restricted. The reason why it's restricted is because, number one, I cannot have, so with the time cannot be negative. So that's why I have to restrict it from 0. And the reason why it's restricted to 8 is because in this case, at 8, you're gonna look at, the water is gonna drip down, right? And then when you reach the bottom of that container, the water is not gonna fill back up, because remember that in this case here at 5, right? That's the lowest here, right? I have no more water. I have 0 water, right? So basically this part of my equation, this part of my graph, the second half does not exist. And for the purple one, at 7 is where I reach the volume of 0. And then after that, I don't have any more liquid. Unless I fill it up, then that's a different story, okay? But then remember that in this case, time can only be 0 plus, okay? And then why we're restricting to 8 is because, like in this case, we want to see both graphs, that's why. But then 5 would be the restriction for the first graph, or the green graph, and 7 would be the restriction for the purple graph, because we reached the 0 volume. So how do you determine the initial value of each function using both the equation and the graph? To use the graph, right, the initial is right here. Okay, so this is where the y-intercept is. That's your initial value. So it's 600 for the first one, it's 490 for the second graph. Now, if you are looking at how do you do that with respect to the equation, remember that your initial point is when your x value is equal to 0. So when time is equal to 0 in this case, right? So you see that time is equal to 0 for both of them. So all what you have to do, you have to plug in 0 into your equation for t and solve for the volume. Which container empties at a greater rate? You guys can find that. How can you tell this? Using the equation and the graph. So you can look at which one is going down faster. So I'm looking at the coefficient here. The first one is 24t squared. The second one is 10t squared. So the coefficient is 24 versus 10. So the larger coefficient gives me a steeper graph, right? So the larger coefficient gives me a steeper graph, which means the green one is going to have a steeper graph, which means it's going to empty faster. All right. Now, this is quadratic. We also have one more type of functions that we're going to look at, and that is the exponential functions. Okay. Now, be careful with exponential functions. So a company is testing the insulating properties of a water bottle. They conduct 4 experiments with different bottles. In each experiment, they fill the bottle with hot water and record the temperature as the water cools. The equations modeled in each experiment are given below. So I have all these experiments here. Now, to graph, make sure that when you're looking at exponential, okay, so, and this is, I noticed that this is one of the main mistakes last semester, is that students forgot to make that n as an exponent, okay? So here is what you need to do. So let's erase these graphs. So we have t equals 75 times 0.9 to the power of n, open bracket, 0.9, and make sure you press that exponent button right here, and then put the n on the exponent, then bring it down, okay, by pressing the the arrow key, okay? And then plus, I think it was 20 plus 20. Okay, so a lot of people forgot that this is an exponential function and forgot to put the n as an exponent, and they did the multiplication, which is totally different. Okay, now they told me to set up my parameters to be between 0 and 35 and 0 and 100. Okay, so I'm gonna go here, 0 and 35 and 0 and 100. All right, so here's one of my graphs. Okay, you can graph all 3 of them or all 4 of them, and then you can answer these questions. All right, so please make sure that when you're entering this as an exponential, make sure that this is on the top like that. All right, if you guys have any questions, please email me and let me know.